Good afternoon and welcome everyone to today's webinar, Road Pricing and Travel Behavior, Evidence from a Large-Scale Field Experiment in Oslo. My name is Julia, I'm Marketing Manager in motiontag, and today I will be moderating the discussion. The Institute of Transport Economics in Oslo recently carried out one of the largest field experiments on road pricing to date, involving nearly 3,000 participants, called Road Pricing, Travel Behavior and Public Support. This is our point of discussion today, and we're delighted to have with us two expert voices who bring complementary perspectives on this important topic. We have today Alice Ciccone, senior research economist from the Institute of Transport Economics, who led and co-designed the experiment, and Jennifer Kuntz, global account director for motiontag. motiontag's mobility tracking technology enabled the multimodal data collection of the study. And in the next 60 minutes, we'll talk through the Oslo experiment in detail and how digital mobility tools like motiontag can power the next generation of mobility studies. Here's how we'll run the session. First, I will let Alice to present the experiment in detail and tell more about it. You can ask all your questions directly in the questions tab that you see on the bottom right of your screen. We'll pick them up and Alice will answer them, if any, after her presentation. Then I will give a word to Jenny, who will present the motiontag's technology to you, and then we'll have a Q&A session, and then you're free to ask any questions that you might have. With that, I will hand over to Alice to start presenting and tell a bit more about herself. Over to you.
Thank you, Julia, and thank you also, Jennifer, and motiontag to organize this webinar. Thank you, everyone, for being here. I will share my presentation now. Let me know if there is any question that I don't see. Just stop me if there is something unclear, and after the presentation, we will discuss more. So my name is Alice Ciccone. I'm a senior research economist at the Institute for Transport Economics in Oslo. And today I'm going to present an article, a study that we run in 2024, a field experiment. And we did this together with my co-author Chloe Garnache and Goril Andreasen from TOI. And Chloe is from the University of Oslo Metropolitan University, and at EATH, Zurich. And we couldn't have done this without the collaboration with a team of researchers at TOI. And Kristen Weber has, in the link, explained more about the coding and collaboration. So today I'm going to talk about road pricing. And specifically, we're going to look at the effect that road pricing can have on travel behavior and how we can shape public support for taxes. So a bit of motivation. Everybody knows, I think, that car driving impose cost on societies, or how economists like to call it externalities. So basically, there are social costs that are not paid by the driver, but is imposed on society. For example, CO2 emission, pollution, accident, congestions, and so on. So today, we have a few instruments and taxes that are used to reduce or restrict the use of car and therefore of negative externalities, such as fuel taxes, congestion charge, and so on. But these type of taxes are generally inefficient. They are not, generally they are too low. They don't completely internalize the cost of these externalities, and they are perceived as unfair. For example, people living inside or outside of a cordon might face completely different prices or consequences to their driving, and there is therefore a lot of opposition, as we all know, like heard from the Yellow Vest movements and other opposition movements toward carbon taxes, for example. So economists have long agreed that the optimal policy for reducing for internalizing externality or reducing car driving to the optimal level will be to introduce road pricing. Road pricing, with that we mean a tax, which price depends on where, when, and what type of car you drive. Optimally, that would be a dynamic pricing, so that it changes throughout the, depending on the, for example, congestion condition. But it can also be a static one, so that, for example, changes if you drive in a very polluted area, in like, for example, rush hour, and if you drive a car that is more polluting, for example, a diesel car compared to an electric car, the price will be higher for the diesel car. So here we are trying to answer two research questions. First of all, whether road pricing, so a tax that depends on where and where, when and where, and what type of car you drive, is really effective at reducing external cost. And if yes, what are the mechanisms? Who is changing behavior? Who responds to this tax? And then we're trying also to look at the same time of what factor can enhance policy support, because we know people don't really like taxes in general, and they don't like new taxes or additional taxes and so on. So we're looking at the role of information, experience with such a policy, and policy design, how the tax is structured. What do we do is that we run two experiments. The first one is a large-scale randomized control trial, means that we randomize people in different treatment and to study the effect of the treatment, being, for example, road pricing. And we run this in the field, meaning that we have recruited people like drivers in Oslo, the capital of Norway, and it's large scale because we have more than 3,000 participants. We use objective data, so it's not self-reported through a survey, but it's through the use of motiontag app, a mobile app that automatically records people travel behavior. And people in this experiment can earn or save money by changing their behavior, or in other words, reducing their driving. And then we combined this with an information provision experiment where we, through a survey, provide information with regard to what are the expected benefits of such policy, and see whether a simple information can really help policy acceptance. So a bit about the design. We set out this study. We recruited a representative sample of the population in Oslo. We contacted about 200,000 people in Oslo. And the first survey, we sent out a survey through email, and the first survey was answered by 23,000 people, of which we asked whether they had access to a car and how much they were driving. And people that were driving at least twice a week were asked to download an app. After this, we observed more than 3,000 people for 4 weeks that we call the observation period. So in the observation period, we could access their travel behavior and understand their driving and calculate how much how much externalities, how much social cost they were generating with their driving. And we divide randomly people in 3 groups. And then after 4 weeks, we contacted them with instruction, telling them how the experiment was gonna work. And then after that, we contacted every week with a summary of their driving behavior and with information regarding the experiment that I'm gonna talk about later. And then at the end of it, we sent another survey and provide the information experiment and see the effect, comparing before and after. The field experiment. So as anticipated, we use motiontag app. Specifically, we used a white label app that is called Spor, which was adapted for the Norwegian context. It's a user-friendly smartphone app and automatically tracks all transport modes with a very high accuracy. We also asked a few questions in the survey, and people reported having no problem using the app, that it was not draining the battery, and it was very friendly and easy to use. So the experimental design consists of, as I said, 4 weeks of observation. In these 4 weeks, we calculated their budget, their driving budget, meaning how much social costs they were creating with their driving. And we also calculated their baseline for biking and walking, so how much they were walking and biking. And to do that, we use prices that comes from official cost-benefit analysis that the Institute of Transport Economics has done for the government. These are the prices that also the participants saw. This is in Norwegian kroner, but basically is about almost 3 euros per kilometer. No, sorry, almost 30 cents of euros per kilometer in urban peak. And then it's higher for gasoline and even higher for diesel. So you can see the prices are changing with respect to location. So urban, suburban, and rural were defined based on how many people live in the areas. And the time is between peak and off-peak. And then the different prices between the different type of cars. And similarly, we also assigned a benefit of cycling and walking, also based on a health benefit. And this is a quick, shows how much the road pricing that we impose is compared when we look at the fuel tax and road tolls that are today implemented in Oslo. So you can see that the price, for example, the little bar is the fuel tax and road tolls, and that's for example slightly higher in urban non-rush, but it's much lower when we look at urban rush, for example, for gasoline car, and it's also much lower when we look at electric cars. And the colors reflect what type of externalities. So we can see very clearly that congestion is the externality that is most expensive. So this was all explained in the instruction. And then after 4 weeks, they received every week a personalized feedback. So basically, they received an email that was made with their information from the app. And we divided people randomly in 3 groups. The first group was the control group, and they only saw like a very simple email that said, "Thank you for participating. This is the overview over your over last week transport behavior." So driving, public transport, biking, and walking. And then we incentivize participation through a lottery. So they were reminded that they should use the app for all the 7 weeks ahead. And then the second group is a road pricing group. So it's a group that were exposed to this road pricing treatment. Basically, they got the same overview, and they also got information about their budget. So how much external cost from driving their cars they created in the observation period. And then this budget was increased by 5% to give a bit of room. And then we were telling them, if you drive less than your baseline, then you can save some money. And we explained them how they could reduce their driving. Similarly, we did that for road pricing plus subsidy treatment, and subsidy here is for cycling and walking. So they got a budget for their driving, but they also got a baseline for their walking and cycling, and we incentivize them to walk and cycle more, given that they could earn money. And I will show you exactly how the email looked like. So we showed it through a graph showing last week transport behavior. The ones that were in the road pricing group, they only saw the black text, not the green one. So they saw your budget for driving was, for example, 30 euros. The societal cost of your driving this week was 20 something euros. So you saved 6 euros. These 6 euros you can pocket at the end of the study. And then if you were in the road pricing plus subsidy treatment, you would also see this text that says your baseline for cycling and walking was 7 euros. And your positive contribution to society this week was a bit higher. So it was about 9 euros. So you earn 3 euros. So the sum of it is about 9 euros that you can pocket this week. There was also a random incentive design where I'm not going to talk so much about this, but basically people were getting paid from 1 week out of the 7 week at random, and that was done to maintain the budget for the project. And then we were suggesting them how they could reduce their driving or increase their cycling and walking simply by walking more, traveling less by car, switching from car to other mode, working more from home, and so on. So the result, please stop me if there's something is unclear, but basically what we find is a 5% reduction in driving externalities. This corresponds to, or it's brought from about 4 or 5% reduction in kilometer driven. There are fewer car trips, and this happen especially off-peak and for non-working trips. We also observe some substitution between car and bike, so people switch from using the car to using their bike, but this happens only in the treatment where biking and walking was subsidized, but we don't see any increase in walking or anything that is significant, statistically significant. And then we look at heterogeneity, so we see that this effect is mostly driven by electric vehicle owners and people that are a bit younger, that don't have kids, that they don't commute daily with cars, that use public transport already, and then they have high trust. But for us, the most striking result is that basically the entire effect is driven by people that have a non-electric vehicle. So people with electric vehicle, they didn't respond to the tax, or at least they didn't do it in a big enough way that we could estimate through our statistical analysis. So the people that were driving diesel and gasoline cars or hybrid, which are also a bunch with non-electric vehicles, they were the ones that reduced their driving the most, almost 11%, like 10, between 8 and 11%. And interestingly, this happens only for non-working trips. And in the treatment without the subsidy for walking and cycling, we also see that we see some substitution between car and public transport and bike. Then I'm going to go quickly through the second experiment, so the information provision experiment. In the before survey, we explained people what road pricing was. We explained, as I said before, that could be a new tax. And explicitly, we said that this new tax was going to replace toll and fuel taxes. It was not an additional tax. And the purpose of this tax was to reduce congestion and pollution. The privacy, they were supposed to think that privacy was not going to be a problem, that tracking were completely confidential. And then we explained the pricing structure, as I explained before. And then we asked how positive or negative they would be towards such a policy. And we asked similar question also for the current road toll system. So we asked this question before and after at the end of this study. And then we added this text. So the green part of the text is the text that was for the people that also participated in the app study. So we told them, you participated in a pilot where about 2,000 people were subjected to road pricing. So this is it's too small share of road user to experience the full benefit that would arise from such a change, from such a scheme. And then for those who did not participate in the field study, but they only answered the survey, they got the black text that says, when road pricing applies to everyone, congestion and pollution from cars will be reduced. We explained why, and we brought some example from other studies that focused on congestion charges, but we thought it could be generalized, and that they generally reduce congestion and pollution. And then what we find is that just this simple information in a text increased by more than 4% support for such a tax. And that this effect is driven by people that own battery electric vehicles. We also study effect of experience. So we are able to disentangle the effect of information and experience with this tax. And we find very little effect, only for those who were exposed to road pricing with subsidies. And we argue that this is, of course, a limitation, because this is a pilot, and even those who experienced the tax, they did not experience the benefit that can come with the tax. So policy recommendation and conclusion. We think that implementing time and location specific road pricing is effective at reducing driving externalities more than the current system. And then combining with an active transport, so cycling and walking subsidy, can encourage more shift towards cycling, and can enhance both overall effectiveness and acceptance of the tax. We see some indication of this, even if the results are not completely robust. We discussed this more in the paper. And basically our conclusion from the second experiment is that communicating benefits of the policy clearly, it's very powerful. And this can be done much better than we have done, for example, just with short messages, but it could also be done with videos and other media. And there's research also showing that the better it's communicated, the easier it is to people to understand. And then for future research, it's important to think about the long-term effect and large-scale effect. So here we were only able to look at people for 7 weeks, and it was only 2,000-3,000 people in Oslo. So it will be really beneficial to look at this from a broader, in a broader situation. And then it will be also really important to look at other cultural and urban context. Oslo has, for example, a very good network with public transport. So how this is different in other cities, it's very interesting. And also it will be interesting to explore more fairness and equity consideration and concern, which is something that we didn't explicitly mention in the study, but it's supposed to have also an important effect on public support. And for example, also study different design of the policy. For example, packaging this with public transport subsidies instead of walking and cycling, or in addition, it could also be very interesting. And here you can get the paper if you want to read more about it. We have published a working paper. It's not published in a peer-reviewed journal, but we are working on that. So here is the working paper version. Thank you.
Thank you, Alice. We received a suggestion to send the slides in the chat as a file, if that's possible.
Yes.
Really appreciate it. And yeah, now I give word to Jennifer to tell a bit more about motiontag, what we do in general, and
Yeah, thank you very much, and thank you a lot, Alice. Very interesting. I mean, I knew a bit about the project, but not in that deepness, obviously. So, yeah, just try to share my screen. Let me see, to give you a bit of an overview about motiontag. Yes, so my name is Jennifer. I'm Global Account Director for motiontag. Sort of we turn everyday phones into world's most honest travel diaries. Yeah, who we are? We are actually 22 experts from the fields of transportation, geodata, machine learning, and data analytics. The company was established in 2015. So it's a solution used by research institutes, ministries, cities, and public transport operators. And of course, we are fully compliant with GDPR standards, and yeah, with solutions focused on transparency and trust towards the user. Yeah, smartphone tracking means actually going beyond traditional survey methods. It is very cost efficient. So you have seamless participant engagement with continuous insights and, of course, delivering high quality data. So let's move from I think to I know how people move. Yes, so our key areas of expertise are focused, on national mobility surveys, so which we do already in Germany and Austria. The technology is also used for public transport revenue allocation. And yes, even Swiss revenue sharing runs on our data. And of course, university mobility research. So that's just a few names, but not to forget TOY, obviously. And of course, the technology is also used for green loyalty programs to push people to greener mobility with gamification and rewards. So how does it work? For this project, we develop a white label app. So once it is set up on the user's device, it collects door-to-door mobility in the background with precise trajectories, timestamps, modes, purposes, which then, of course, deliver very insightful mobility insights. Yes, so, and of course, feel free to reach out anytime to hear more. Thanks.
Thank you, Jennifer. Thanks. I would suggest now we can turn to a bit of round of Q&A. Please don't forget that you can drop any questions in the chat or in the question tab. Both Jennifer and Alicia would be very happy to answer them. As for myself, I have a few questions as well. First to Alicia. So your study shows road pricing reduced driving externalities by about 5%. What kinds of trips were people actually cutting back on to compensate for it? And what does that reveal about how such policies really affect daily travel?
Thank you, Julia, for the question. So as I said, the trips that were cut the most were trips that happened outside of rush hour and for non-work related trips. And this is somehow different from previous research. Other researchers have found that people were, for example, changing their timing. So they were, for example, trying to drive outside of the rush hour. We didn't find that, and we tried to discuss this a bit in the paper, but it might have something to do with the fact that Oslo already has road tolls that are time differentiated, so that we already have higher price for rush hour driving, and also so maybe people already have adjusted for this. So people that are driving rush hour, they might not have another option. And then also this is very correlated with people driving EV and non-EV. So because we find that people responding to this, to our study are people that don't drive EV, they are also, normally they drive less in rush hour in urban areas. And they, for example, EV driver use their car much more to commuting, to driving to work compared to the others. So these are all explanations of why we find this result. And also this is something to do with the short timing of this study. We can only look at adjustment in the short period. So people, for example, that drive to work might not be able to adjust this behavior in a very short period. It may be something that can be adjusted in the long run. And there is also some literature that supports this idea.
Thank you. We've got a few questions from the guests, so I'm going to go straight to those. One of them is, out of the 3,400 participants that downloaded the motiontag app, how many responded to the after survey? What measures did you take to motivate people to participate again in that after survey?
Okay, thank you. So we had about 23,000 people to answer the initial survey and almost 20,000 or 18,000 that answer the second survey. How many of the 3,400 participants? I'm not sure at the moment. I think we have it in the paper very clearly, but I think a large majority. Also, the 3,400 people that downloaded the app, not everyone participated in the full field experiment because some people drop out. So we also look at differences in dropout rate between the different groups, and we find no particular signs of attrition, but there has been a dropout. So the number of people that we consider participating in the field experiment is a bit less than 3,000. And of those, then a large majority is also answering the second survey, but I don't have the numbers right now. And what measure we use to motivate people? We incentivized all participation both in the surveys, in the field study, with monetary reward. So we normally use lotteries of different value. For example, we give the lottery is a great tool because it allows us to keep the price low enough, and it gives an incentive to people because it's a high reward. So, for example, to answer the first survey, one person won, one or two people won about 500 euros. But out of 23,000, so that was it's a good measure for us to keep within the budget.
Thank you. I think the next question was is again to you, Alicia. If you can please elaborate on the explanation of road pricing, quote unquote, that was provided to participants. How practical is it from government authorities' POV to opt out from regular vehicle taxes, tolls, and shift to road pricing, given the obvious revenue shortfall?
I'm sorry, I don't see the question. I didn't understand it.
It's in the question tab. I guess we can put it here. Can you?
Yeah, the explanation. So the explanation of road pricing that was provided to the participant is, well, we attach all the instruction and all the text in the paper, so you can read exactly what they saw. But it was a long explanation, and there were also links that pointed to more explanation. We created PDF to explain what externalities are, what road pricing would be. But it's important to say that road pricing has been discussed. It's been part of the public discussion in Norway because the government has explicitly talked about introducing road pricing, and it was officially evaluated. Now, a few months ago, it was decided that the government will not go forward with this particular proposal. But for example, the city council in Oslo has said that they are still evaluating this possibility. And how practical it is, of course, every change requires some costs of adjustment. But for example, one of the main reason in Norway is that revenues are declining because there is a high percentage of electric vehicle owners in Norway, and this is also a very important part of this article, an important contribution. That this is probably the first article that have half of participants owning an electric vehicle car. So this is where road pricing is important, is that it doesn't only target externality through, for example, fuel tax, which have been for very many years the center of much research and focus from a policy perspective, but it looks at the amount of kilometer driven also for electric cars that, for example, don't use fuel. So any shift, it's challenging, but I can say that Norway has already discussed this in the public debate, and there are a lot of possibilities in place. So it's totally a realistic option that I think is going to be implemented in the near future, actually.
Thank you.
I see some other question.
Yes. If the participants were only paid for behavior change in 1 out of 7 weeks, and if you're expecting a lower response to this.
Yeah, thank you for your question. Yes, we used random incentive design. So we discussed this in the paper, and we actually expect a higher response because basically we argue that because they were paid only 1 out of the 7 weeks, the response that they have might reflect that. It may not. It may be that they have understood that every week counted the same, but in the end, it could also be that our estimates are 1/7 of what the real start. Like the point is that this is an experiment, so there are a series of tweaks, experimental tweaks that we had to implement. For example, the budget, that we gave them a budget and then we reduced their budget given the amount of kilometer that they drive. And this is very similar to Hinterman approach, the other paper that is suggested here. So, and this is also an experimental approach, because we are in no position to ask people to pay taxes to us, and how that will change when if the tax is implemented in reality. That's also something that we don't know, but we also argue in the paper that it could also mean that the effect that we find is a lower bound, because we can think in terms, for example, of house money effect. We get money that isn't ours, so we are not so attached to it as it was actually earned money. So yeah, these are all things that we discuss a bit more in the paper, and I'm happy to talk more about it.
Thank you. The next question was, what are the main differences to the congestion charge in London? If you can answer that.
I think the congestion charge in London is it does not depend on kilometer driven. So that's the main difference. As most congestion charges, they are a fixed flat rate.
And we just got another question. Were participants actually paid with real money for behavioral change, or what means paying exactly?
So this is what I was trying to hint before, that they paid with real money, but it wasn't their money. So we gave them a budget. We said, you can, every week you have 30 euros. And if you drive as much as you were driving before or more, you will not earn anything. So, but we will also not lose anything. But if you drive less than these 30 euros, and we explain how the money value is attached to the driving through those road pricing. If you drive less, then you can save money from these 30 euros. And everything you save can be yours at the end of the study. And we explain also more clearly than what it was presented, that we will extract one of the 7 weeks at random. And the week that is going to be extracted will be the one that you get paid for. So that's an incentive to always save, so that you don't know which week you're going to get paid for. But they all got money from us, or they could also donate it. So we, because of privacy concern, if we want to send them money, they have to give us their some information, some detailed information about themselves. And if they didn't want to, they could decide to donate the money. So we also raised quite a bit of money to donate to different causes that they could choose.
Thank you. The paper that has been mentioned by Professor Axhausen, Pickle transport pricing in practice, if I'm not mistaken, is also supported by motiontag technology. And from there, I'm making a smooth bridge to asking Jennifer, because study relied heavily on motiontag passive tracking. From your perspective, what made your technology particularly well suited to capture those kinds of detailed changes in travel behavior?
Thank you, Julia. Yes, I mean, it's easy to use. It's sort of passive. It's not intrusive. So the users are always in control. They can turn it off easily. And of course, it works in the background. So without any user engagement, of course, it's good if they engage. But the technology, it detects 12 different modes of transport automatically. So also including the travel purpose detection. And I think what was quite interesting as well in Oslo is that we added the GTFS data in June 2024, so which actually pushed the accuracy to 98.4%. But I think, keep in mind that Norway sort of sets the gold standard for GTFS, because, I think Entur delivers everything. So it's one unified, validated open feed for the entire country. So clean and consistent and complete. So we can add also different sources to the data to get close to the 100%, which is impossible, obviously, but yeah.
Thank you. Alice, I want to just jump back quickly to your presentation. You found that non-EV drivers responding strongly, but EV drivers hardly change their behavior. As you mentioned, why do you think that is, and how should policymakers interpret this and work with this?
Yes, thank you. We're still we have a discussion section in the paper where we discuss several possibilities. I can say that electric vehicle owners and non-electric vehicle owners, they are different. So there is a self-selection there. People choose electric vehicles for some reason. A bit of context for non-Norwegian listeners is that Norway has a lot of facilitations and subsidies for electric vehicles. For example, they have quite a lot of reduced tax. They have lower prices for road tolls. Until a few months ago, they were able to drive in the public transport lane. So there are differences. And but what we find in the paper is also that yes, they don't respond to prices. We also look at their baseline, like demographic, and we also see that there are differences there. So people, they have electric vehicle, they tend to be a little bit richer. But those differences, they are not that big, or at least not that big to actually justify this large difference between response. So we're still we're very happy to also get feedback if people have any suggestion. What we think is that what I was saying before is that yes, people that have electric vehicles, they use their car to drive more to work. They drive more in the peak hour, and they drive more in urban areas. And this type of decision might not be something that can be changed easily. So it's more like a 0-1 type of decision. Either I drive to work with my car, or I go with public transport. And that might be something that in the short run, it's not possible to adjust. So this is what we think, but also like in terms of alternatives, maybe people that drive a non-electric car, their driving is already very expensive. So for them to have this additional price might have, tilted them to switch to other modes. But for electric vehicle owners, maybe their driving is not as expensive, so that extra price doesn't make them worse off enough to change to a different mode. But it will be interesting, for example, to see the effect if this was combined with the subsidy for public transport, for instance. As we see the people that use public transport more, they are easier to, they adjust more easily.
We have a small question regarding the GTFS real-time data. Jenny, maybe you can answer that.
It's not currently, it's not real-time data we're using. It's actually just a static sort of timetable data, but there are different feeds for real-time data for different public transport operators in Norway. So it is sort of on the pipeline as well to use those real-time feeds as well. But currently it's just the static timetable data, which is already, quite valuable.
Thank you. And then again, the question is to you, Jenny. So participants also received personalized feedback about costs saved or benefits earned. In your experience or motiontag's experience, is that a significant user engagement factor in studies like this and similar ones? I mean, we're working a lot with universities, so maybe you can share some other experiences.
Yeah, I mean, I think nudging or personalized information is clearly more engaging. So, which is only possible with a tool that sort of can both record and speak to user, obviously. So, with push notifications or other ways as well. So, yeah, a smartphone is compared to normal tradition surveys or even GPS trackers. It's not only about getting the results of the study, but also being engaged during the study, right? Hope that answers your question.
It does. Thank you. Alice, in the large-scale experiment with around, as you said, it's thousands of participants, how did you handle recruitment? To what extent do you think the results are generalizable to broader population? Did you gather the percentage of the population that you intended?
Yeah, thank you for this question. The recruitment was a big effort, a very big effort. It took also quite a long time. So, and we tried to have as representative as possible the population that we were going to engage with. Of course, we wanted to have people that were driving their cars. So we don't have like the people that are participating in the field experiment, they are not representative of the general population, but they are very representative of the driving population or the people that drive a car. And we compare this with the national survey, national travel survey from Norway. And we also try to look at comparison to understand how representative our sample is using register data from the Statistic Norway. And we find that the sample is quite representative. There are a bit of differences from the general population, as I said, once because they are people with a car, and also because it's the recruitment method that we used was email. So at TOI, we also did experiments, the understanding, we work a lot with surveys and recruitment. So we really are trying to understand how to optimize recruitment. And we see that there are like different methods that can be used, like normal post, email or SMS, and different methods provide a bit different result. So the representativity, for example, with emails, we tend to have people that are a bit richer, a bit younger, so that they look at their email more, a little bit more educated maybe, but these changes are quite small. So I think we can still say that this study is quite representative and can be generalized to some extent in Oslo, to this context, of course.
What method would you say worked the best in your context and the worst? Like which channel?
So in our context, we only use email recruitment, which in my opinion is the most it's the cheapest one that also yield the quite good results. I think SMS are a bit too intrusive. People don't trust receiving SMS from unknown sources. This could be different if you have a panel. So if you know, like people know who we are and like they are getting this SMS over time. And mail, like standard mail, I think it's probably the most representative, the method that yielded most representative results. But we didn't have time to use that approach. So, and also it's more costly than email. So, but I think combination of different approaches might be the best.
Absolutely. I just have to sort of jump in as well, because you said something which I find very interesting is as well that sort of the results from country to country are different. For example, I mean, in Switzerland, we realized that sending emails, people were too scared. It might be spam or something. So whereas in the Nordics, you have the completely different approach. But for example, in Switzerland, they discovered that sending out a paper, really like snail mail, a paper letter as invitation, the response rate actually sort of went through the roof compared to the email, right? So, which I find very interesting that it's such a different experience.
I think we find similar experience, but maybe not that different for us. And also it's important, I forgot to mention, it's important where you, like we applied to the national registry to get this representative sample. But there are, of course, other market research companies or other sources where one can get similar samples.
That's super interesting. We have a question. What do you think is the biggest challenge for the transport revolution in terms of the modal shift? It's a very future-oriented question.
Is it for me or Jennifer? Maybe
I guess for both.
I don't see the question though.
It's in the questions tab.
I can't find it. That's why.
I can just show
the
you.
biggest.
Thanks. Convenience, I would say. And especially for Germany, I think people are just sort of it's a car country. So, and people actually grow up, having the only goal for your 18th birthday is having a driver's license and stuff. So I think shifting the focus from that, and sometimes also the offering in the urban areas is not that good. So people actually need a car. And I think, the options would be on top of my head right now.
Yeah, I think for me, public transport might be the key. I'm originally from Italy, Torino, which is a very car-based city. And when I moved to Oslo, I think my life changed because also when I was growing up, my goal was to get a car so that I could get my freedom and go everywhere. And then since I've been living in Oslo, the public transport is so convenient. So it's so simple and it brings you everywhere in a very short time. But of course, this is different for different cities and how it is shaped. But also biking, I think that's even more freeing for some people because then you don't even have to wait those 5-10 minutes. But I think those are the challenges or the points where one have to focus. Make public transport accessible and convenient and easy to use and even cheaper if possible. And also and I think Oslo is also a very exemplar, like a very good place to look at the restrictions that have been put around car. For example, the center in Oslo has completely removed parking. It's really hard to drive in the city center of Oslo. So it's not made for car, it's actually made for walking, cycling, public transport, and so on. And I think this, the architecture and urbanism is a central role for this.
Yes, I agree. Since we're on the topic of the future already, Jennifer, the last question for you. So if a city wanted to roll out this on a much larger scale, say tens of thousands of participants, what are the main hurdles? How do you see digital mobility data shaping the future of mobility research?
Yeah, I think the biggest challenge would be the recruitment. And I think, that's sort of how to get the people actually to use the app. And I think it's always sort of the story as well. A story needs to pick you up. So transparency towards the user. What do you want to do with the data? Why should I participate? And of course, what always works as well is incentives, right? So, or I don't know, make it fun, make public transport fun again. I don't know, have a lottery or something, and just something to give back to the users and the community. I think to me, recruitment would be the biggest challenge.
Mm-hmm. Thank you. Just being mindful of time, I would suggest that we can wrap this up. I thank a lot for all the questions and participation. A huge thank you for you, Alice, for being with us today and presenting your findings and research. Thank you, Jennifer, for also being here with us. Yeah, I just remind again, if you, as a participant, miss any part of the webinar, you will receive a full recording after we finish. So you can rewatch at any moment of your convenience. If you have any questions, you can, of course, also reach out to us, and we will answer any of the questions post factum per email. Yeah, thank you for being with us, and have a great end of the week.
Thank you. And thank you, Julia, for
My
moderating.
pleasure.
Thank you very much. Can I just say that I tried to put the presentation here in the chat and I was not able to, so maybe Julia, you can post it somewhere. I'll send it to you.
Yeah, I will share everything per email to everyone. So yeah.
Thank you very much, everyone, for the good questions, and please reach out to any of us if you have more and would like to discuss. We are very happy about that.
Yeah. Thank you. Goodbye.
Thanks.
you.
Bye.